All right, so at this point in the course, we've learned enough about lists, tuples, loops, functions, reading from files that we can start to combine them into creating a little bit more useful, more interesting programs. And we're going to, in exercise 20, start processing a text file containing um, data. So in this case, it's going to be rainfall data for the state of New Jersey over the last 120 or so years. And this is data that was compiled by Rutgers University, and it's publicly available. And I just downloaded it and made it into a text file. And we're gonna this exercise. We'll be building on this as we learn a little bit more advanced data structures like dictionaries, and in classes we'll revisit this exercise and kind of improve and simplify our data structures and the way we organize our information and add more features to it. So this will be sort of a recurring exercise that we'll keep coming back to a few times and adding as we learn a little bit more about Python. But for this first exercise, we're going to write a program that's going to read in all of this rainfall data and allow the user to query it, to ask questions, basically. So before I explain the rest of the program, let me just give you an idea of what this looks like. So I've got the New Jersey rainfall text file here. Let me expand this browser. And it's a simple text file where each line represents a year, and we go from 1895 down to 2014 was the last completed data set. And each column represents the amount of rainfall in inches that we had in that month. So we've got January, February, March, April, all the way out to December. So the text itself is fairly easy to process. It's an easy it's a very typical type structure where each column is delineated by a space or a tab, and we can process this information pretty easily. So what I'd like to do for this exercise is allow the user to type in a given year and month, and I'll allow them to type in a month just by a number. So January would be 1, February would be 2. And the program will report back how much rainfall was given during or we had during that particular month. In addition, I'd also like to print out the average rainfall for that month over the course of the entire data set. And that'll be a little bit more difficult. So we'll first start by making sure that we can process the data and store it, right? We want to be able to store the data in our program. And the way I'm going to do it this time, and again, this is something we'll revisit, is using a list of lists, basically, a list of yearly rainfall data. So we're going to construct a table. So the first step is to get that data structure in memory, and then next we'll try to do our simple lookup, and then finally we'll add the average rainfall. Okay, so I've downloaded the data, and again, just so we know what we're looking at, it's a pretty straightforward file format. We're going to read this thing line by line, and we're going to assemble it into some sort of a data structure that we can work with. So we know how to read files line by line, but how are we going to actually store the data? Right, so the way I'd like to attack this time is by having a list. So I'm going to draw these brackets. All right, so this is a primary list, and each element within the list will be a tuple. Right? And that tuple will have the year, so 1895, followed by, I think we'll probably do a list of rainfall data. All right, so I don't remember what 1895 was for, but we'd have 2.2, 3.1, 0.6, on and on. 12 entries for each month in the year 1895. Right? So that's our tuple. Right? The second tuple would be 1896 with the monthly rainfall data. And we'd go all the way out to having a tuple with 2014 as the last entry. So we've got a list where each element is an individual tuple, where the first element in that tuple is the year, and the second element in that tuple is a list of monthly rainfall data. And so the trick of this program is going to be first to build that data structure, and then also to be able to query it, to look up given rainfall by month and by year. All right, so I like to break things up into functions here, and I'm going to design all the code that's responsible for creating the table in one specific function. So I'll call it load table. Right? And the purpose of this is to return a table, a list of tuples from the New Jersey rainfall.txt file. And so, again, going back to our sketch, we're going to start with a list, and I'm going to call that years. From there, I'm going to open up this text file. And again, I've saved the New Jersey rainfall text file to the same directory as my program, so it's right there. And I'm just going to dump all the years for now to the screen, just so I can, just evaluate my progress here. So I'll return years. Again, we don't want to write too much code without running it, just making sure it's looking like we think it should. Now down here, I'll just say, I'll call table equals load table. So table's not going to have anything in it at this point because I'm just returning an empty list, but I at least get to see it print out to the screen. So now I'm running my actual program, and yeah, so I already see a little syntax error. All right, so I see it. We got new lines. That's really not that important right now because we're eventually not going to really be printing this out. But I'm successfully picking out each line in the code in the file. All right, so the next part here is that for each one of these lines, I need to parse this into my data structure corresponding to a year, which is really just a tuple. Right, so remember we've got each individual year should be created or should be represented by an individual tuple with the first element as the year, which is the first column in the text, and the rest of it contained as a list. So I'm going to create a function. I'm just going to say years.append, and I'm going to say make year tuple. Okay, and I'm going to pass in the complete line of text, the year. And now let's break that out into a function. And again, this makes sense to start using your functions kind of liberally so each function doesn't do too much. You don't want to have big long functions that have lots of moving parts to them. You want a small function to do a very specific job. So loading table is just a sequence of opening up a file. By the way, I have to close the file. Just do that so we don't forget. Load table is just a task of opening up the file and then processing each year, rather than having all the code to process each year inside this function. I'm going to tuck that away into this. Okay, so year is a sequence of fields, right? So this is the input, one line of text. And I want all of these, we can call these tokens, right? The first token is the year, and the remaining 12 tokens are the monthly rainfall data. So in Python, I can split a string by white space, which is this, right? Whether this is 5 spaces or a tab, it doesn't really make a difference. And we can use that to get an array of string tokens, so strings representing each one of these fields. So let's do that. So we'll say tokens year dot split. Okay. Now the actual, and actually let's call this year line. The actual year is, I'm going to parse it as an int, it's tokens 0. It's the first token in this list. And the remaining part is the rest of the list, right? Or is the rest of this token. So we can say like rainfall equals, and we can say tokens starting at 1, right? And that would give us our list of rainfall. And we could return the tuple year rainfall. Okay, so the first token will be converted to a year, and the rest of the tokens, starting at 1 and going all the way through the end, will be looked at as rainfall data. All right, the monthly rainfall. So let's do this, and let's go ahead and print and see our structure. Right, so it's pretty hard to see, right? We're sort of losing some context here, or losing some of our ability to easily make sense out of this. But if you look at this line or this table starting, we've got 1895, and then we've got a list of 12 individual values, right? And then we've got our next tuple in 1896 and a list of 12 individual values. That looks pretty good. The only thing I do notice is that these are looking like strings, right? So these are actually string values, and that's not really correct. And if we want to go do the averages later on, we probably want them as numbers. So we need to convert each one of these remaining tokens into a float. That's actually very convenient to do using a list comprehension. So if you remember from the textbook, the syntax, we can specify some transformation for each x in a given list. So the transformation is to take each string out of this and convert it to a float. If I run this now, it looks pretty much the same, but you can see that these are actually true numbers. And that makes a big difference later on. We want real, actual values. Doesn't print out as nice as we'd like, but we're not really interested in printing out. Eventually we'd like to be able to do some lookups on this. Okay, so let's allow that user to now start to query by year and month. First off, instead of printing out the table, after I load the table, it'd be nice to tell the user a little bit about what we've found. So I'm going to first off find the first year. So the first year, remember, if we look at this, the list that is being returned as our table has a first tuple, and a first entry in that tuple is the first year. So if we say first year, we can say table 0 and 0. And we can do last year as saying give me the last element, index with -1, and the 0th element within that tuple. Remember, table 0 gives us a tuple, table -1 gives us a tuple. In both cases, the year is the first element in that tuple. So loaded rainfall data from first year to last year. Okay, so we've got loaded from 1895 to 2014. At this point, let's allow the user to type in a value, and I'll sit in actually a loop. I'll say done equals false, while done equals false. We'll get the year from the user. And let's say if they want to stop, if they don't want to look anything else up, we'll say -1 to stop. So if year is equal to -1, done equals true. Otherwise, we're going to ask for the user for the month. and I'll specify 1 through 12 to make that clear what I'm expecting. At this point, we would go find the average. Let's just make sure all of our logic works. Okay, so I can say 1995, month 3. I would print out, how much rainfall was on that particular month, but then I would try again, right? So I could do 2014, 8, and then I could do -1 for the year and stop. All right, so I've got year month. How do I find that particular amount of rainfall? So first of all, again, if we look back to our sketch, if the user types in, like 1896, right? Well, how do I find 1896? Which tuple relates to that? Well, in fact, it's really just the year minus the first year, right? If I do 1896 minus 1895, I would get element or tuple number 1. If it was 1895, I'd get tuple 0, and you can sort of do the math, right? So we can figure out which entry within the list corresponds to the year the user types in by just subtracting that first year. So let's do that. I'll just print out all of the all the rainfall. So year, table. And year minus first year. All right, so I have that variable already. Okay, so, and I'm just printing out all of the data right now, but that's okay. And this is a good opportunity to actually check to make sure that things really are working. Never completely trust your program, always double check it. So if I scroll down to 1996, I get all that data, and yeah, that's matching up. So I can see the record for 1996, and now the question is, well, how do I get the specific month, right? So if I typed in April 4, this is January, February, March, April. I should do 4.95. Remember that this list is 0 based, right? So I need to access the second element in the tuple, and then I need to access the fourth element, or the fourth element in this tuple based on the user typing in month number 4. So I want that entry. I want the first tuple within it, right? That's going, or the second tuple within it. That's indexing past. So remember, this would give me the actual year. This is giving me the list of months. And now, if I type in month, I've got the actual monthly rainfall. So let's kill this. Let's try that again. 1996, 4. All right, now that's 3.8 though. If we look back, we said January, February, March, April. I'm getting one more, and that's just because the user typed in 4, but they're thinking 1 through 12, and actually our list is indexed 0 through 11. So we need to fix that. Month minus 1. It's not that great. Whoops. It's not that great to just print out a blind number like that. We probably want to add some context to it. What we can do is we can actually print out the full month and everything. We can create we can figure out, let's say, which month that actually corresponds to by having an array. So months equals, and it could be a tuple too, it doesn't really matter. January, February, and completing that. Okay, so we've got our months here, so we can print out something like this. Rainfall in months, month minus 1. we'll put inches as the unit. Okay, and so now we have, I got a little extra space here, but now we have a really nice printout. The rainfall in April of 1996 was 4.95 inches. Take that space out, and we've just used a nice little lookup tuple to index into a list of strings. All right, finally, we're on to average. How do we figure out the average in April across all of these months, for instance? Well, again, we go back to the listing, and now we've got this big long list. We've got a big long list of year entries, and for April, we're interested in getting all of these values straight down the table. For every single year, just pulling out just the fourth month. So I'm going to write a function that does that. Def find average. And I'm going to pass in the actual month as an index. Right? So I'm going to say average equals find average month minus 1. Right? So again, maybe even to save myself all of this stuff, I could have subtracted off 1 right away, but I'll leave it as it is. So I'm going to need to now get data about this month for every single year. And again, this is where a list comprehension is really nice. So we can think about it almost like a for loop, right? So for y in the, I got to pass in the years table actually as well. Let's do that. Can't do this without the table. For year in table. I'm going through every single year, and I actually want this month from that year. So to get that month, I would do print, or I'm not going to actually print it out, but let's just see it come out. I'd be looking at table, sorry, not table, just year. All right, that's going to be a tuple. Remember, right? So that's a one individual tuple. I'm going to be looking at the first element, right? The second element, element index 1. That's a list, and we want that month. Let's just look at that. It's going to be a pretty bulky output, but right, so we see all these values coming out, right? We can test that, right? We can look to see if that makes sense. Let's scroll all the way up to 1895, 4.72, 4.72, 1.31, 1.31. So again, I'm kind of every step of the way trying to add some visibility to this program and making sure that I can see all these numbers coming out. So at this point, I'm very confident that I'm able to access each one. And now the question is, well, what do I want to do with each one? I want to add that to a list, right? I really want to do something like this. Start that out as a list, and incrementally, I'll add to the list. And then I would have my entire list of values. I don't really need to do all this syntax. This looks exactly like I'm cycling through a year in a table. I'm transforming it by pulling out a particular month and I'm appending it into all years. So in Python, it's much simpler to say, for each y in table, right, I want to access y1 month. And there's my list comprehension. That's kind of a real succinct way of writing that for loop. Again, it's the same as doing that for loop and appending. Now at this point, I've got every single monthly rainfall for April or for whatever month I've passed in for every single years, and it's in a list, and I can compute the average pretty easily. I can just do sum all years. Remember, the sum function is built into the list. It can calculate the sum of all the numbers and divided by the length. Pretty straightforward. All right, there's all my entire average. and I can say print the average rainfall for specific month is whatever we computed. Okay, so again, 1996, we'll do April, and we're printing out that the rainfall, the average rainfall was 3.71. Now we need to test that, and I actually I did embed a link to the actual raw data, and they in fact do have all the averages, which is I conveniently stripped that out of the text files so we could do this exercise, but they have the average already, and so now we can kind of easily you'll look at it compared to something else. And we see that the mean is 3.72. That's pretty darn close to what we have, 3.71, and we've rounded. We didn't round when we printed; they did. So that's spot on, right? And you always want, whenever you're doing something like this, if you don't have access to some other source of the data or source of the answer, then you might even have to go through and copy all of this data into Microsoft Excel or something and calculate the average. It's always good to independently verify these calculations. But you notice that all, throughout this entire process, every time I read a little code, I tried to test it. Right? I tried to make sure I could test it. I printed it out, and I worked very incrementally. This was a larger program. It's certainly larger than the previous programs we've written in these exercises, and I want you to try to use that style of programming when you're working through your assignments. As these assignments for this course get much larger, it's going to be really important that you take small steps. Take a small step, print out some temporary intermediate results, verify that they make sense, verify that they work, and work methodically rather than trying to sort of race to the end, right, or to get the whole thing done all at once. So we'll come back to this example several times throughout the remainder of the course to add on to it, to manipulate our data structure and make it a little bit easier to work with.